questions on the week 6 WRS, and so I'm going to answer some questions on the week 6 WRS. And when checking some of them, I noticed some similar mistakes, so I'm going to go over a few things. One of the questions asks for the product of two decimals. So we're going to look at how to multiply two decimals. Remember, product means multiplication, the answer to a multiplication problem specifically. So I'm going to look at the product between 46 and 2/10 and 1500ths. All right, it doesn't matter which one goes in on top or which one goes on bottom. You're not lining up decimals for multiplication. You're simply multiplying just as you would a long multiplication problem. I always put the one with more values up there, so more place values. They both have the same number of place values, so I'm just going to list them in order this time. So 46.2 times 1500ths. When I multiply, I start with the place value furthest to the right, and I multiply with that place value to each of the individual parts of the other number. So 5 times 2 is 10, and I carry the 1. 6 times 5 is 30, plus 1 is 31, and I carry the 3. 5 times 4 is 20, and I add on the 3, so I have 23. And then I hold my place value, because now I'm going to multiply with the 1. So technically I'm multiplying with 1000ths. So I need to put a 0 there to represent that place value. 1 times 2 is 2, 1 times 6 is 6, 1 times 4 is 4. And then I add the two problems together, and I have 0, 3, 9, and 6. Here is the hardest part for you guys right now is where do you put the decimal? Since you're not lining up, you don't just put the decimal down. You have to count the number of decimal places you have. So we have 1 decimal place here, and 2 decimal places here, so I have 2 decimals here. And I simply have a total of 3 decimals, so I move it over 3 place values. So my answer is going to be 6 and 9300ths, or 6 and 930 thousandths. Either way. The other problem we had was with quotients, or when we were finding the answer to a division problem. We're looking at 30, I'm making one up. I'm looking at 30 and 2/10, and I'm dividing it by 2. Division, I am not going to have remainders anymore. I'm going to go until I get to the end of the number, or it ends up repeating. And we'll get to that later on in the year. But I simply bring my decimal straight to the top, and I divide. 2 can go into 3 one time. 2 times 1 is 2. And I find my difference. It's a 1. I bring down the next place value. So I have 10 now. 2 can go into 10 5 times. 5 times 2 is 10. And I find the difference. And I bring down the last one. It's a 2. 2 times 1 is 2. And I have a difference of 0. So I can stop. If I didn't have a difference of 0, I can add on as many zeros as I want, because that would not change 30.2. 30.20 is 30.2. 30.200 is 30.2. So I can add as many zeros as I want, and I can continue to bring them down until I get to an end. Then there are problems that go on forever or that repeat, and we'll discuss those, like I said, later on. So my answer would be 15.1. The other question we had on what is a reciprocal. We talked about reciprocals last week when you had to answer the problem as to what two numbers multiply and get 1. And that's what you wrote down as your definition. So we look at a number 4 over 5. Well, in order to get 1, we would have to multiply by the reciprocal. Well, that is simply the number flipped upside down. And the reason that happens is because you want the numerator and the denominator to multiply and be the same thing. So 4 times 5 is 20, and 5 times 4 is 20. Well, 20 divided by 20 is 1. So your reciprocal is 5 over 4, which is just the number flipped upside down. If I asked you what the reciprocal of 1/6 is, it would end up being 6 over 1, which is just equal to 6. If I asked you what the reciprocal to 5 is, well, you would have to make it into a fraction for you to look at a numerator and a denominator. Anything divided by 1 is itself, so I'm going to put it over 1. Well, when I flip it, I have 1/5. Those would be reciprocals. When multiplied, they'd equal 1. If I add a negative to the problem, the reciprocal is still the numerator and the denominator flipped. So the answer stays negative, but it's a negative 4 over 3. There is a question on the WRS asking for another name for a reciprocal. I'm going to ask that you Google what is another name for reciprocal. And this will prepare you for when we start to multiply and divide with fractions. The last one is a square root. And you're probably saying, oh, square root's not on there. It technically is, because I gave you a square root problem. Last week we looked at what perfect squares are. It's the multiplication problems that multiply to get a perfect square, and we actually call them squared. So when we looked at 2 squared, we looked at a square that was 2 by 2. Well, 2 squared is 4. And we looked at squares that were 1, 2, 3 by 3. And we called that a 3 squared, which is 9. So we looked at, this was in week 5 that we looked at these perfect squares. So this week, we gave problems like this that have the square root. This represents a square root. And what it's asking is, what is that root number that's being multiplied by itself to form a perfect square? So what number times itself is 4? Well, what number times itself is 4? It's 2. We're only looking at the positive roots. So it's not going to be plus or minus for these. Here, if I looked at the square root of 9, it would be 3. And then that ends so far the questions I have had on week 6.